2 minutes to do. Yeah, they have changed it, right? For now, we need, oh, yeah, with mobile for authentication also on. During contest, I will not discuss much about it. Please try to speed run. Okay, okay, 1 minute to do. Today I just saw the new, like, while registering, they're asking to set up two-factor authentication. Hmm. I have added my mobile number there. That is actually good initiative from the LeetCode, right? That's how you can reduce the number of cheaters. 1 minute to go. Recording. 181 LeetCode Biweekly contest. Okay, good to go. Hmm. I hope I will not fumble the first question today. No commitments before the contest. Hmm. Okay, trying the contest. Given and digit x, a number is considered valid if contain at least one occurrence of s. It does not start with s. Return true. For and is equal to at least one. Okay, given integer m and digit x, while n is greater than 10, when b is equal to n minus 10, if b is equal to x, return true minus n divided by 10, return right. First test case is at least one occurrence in that return true n is valid, otherwise return false. At least one occurrence of x, right? B is equal to m mod 10, b is equal to x. It does not start with digit x also. Okay. And wait. True, okay, is equal to false. Make okay is equal to true. Here we'll check. Okay, and it's not equal to x. False. Why there is a false here? We have and n is 10. Yeah. True, false, false. Correct. Let's move to next question. Compare sum of Bitonic part. You are given, you are given a Bitonic array, none of length n. Split there into two parts, ascending part, descending part. On day 0, your peak element. The peak element belongs to both parts. Okay. Return 0 if sum of the ascending part is greater. Return 1 if sum of descending part is greater. Minus 1 if both are equal. Okay. In sum, 1 is equal to 0. For and j is equal to 0. I is less than n. I plus plus. N is equal to 9 dot 5. Previous is equal to minus 1. No, previous is equal to nums of 0. Okay, let me start with 1 minute. If previous is less than ascending, right? Strictly, strictly or strictly greater than, okay. Nums of I has some 1 plus is equal to previous. Here we have to do some 1 plus is equal to nums of I. Okay. Else, let me in 1 is equal to minus 1. Else, some 1 plus is equal to previous. Okay. No, some 1 is equal to num of I in 1 is equal to I and here break. Now let me calculate sum 2 is equal to 0. Sum 2 is equal to nums of int I. Previous is equal to nums of int I and start with this. I is equal to int I plus 1. I less than n. I plus plus. Okay. Sum 2 plus is equal to nums of I. Let me first check. We have someone, we have some tools, we get a runtime error, right? Why runtime error? Still runtime error. Still runtime error. What the hell is going on? Okay, wait, what? Split there into part from index 0 to peak element, from peak element to index 1, 1 and 3. And so on. This should not be error, right? Yeah. Sum is equal to Bn comma m comma 0 full is equal to 0 and 3 is equal to none and 0 for int I is equal to 1 I is less than n I plus plus where n is equal to none for I if p is less than none for I continue else index is equal to I and trace 3 is equal to none for I. We have index. That is 3, 0, 1, 2, 3 should be 1, right? 3. We're not even going inside this 3 is 1. Okay. Okay. Then someone is equal to 0. So, and yeah, I is equal to 0. I will written in x I plus plus someone plus equal to 1 plus I. And something is equal to 0. Something. If someone is written and say, yeah, written 0. Else if something is written from 1, written 1. Else written minus 0, 0, and 0. What's the fuck? And 1, and 2, and 1, and 3. 4, 3. 4 and 3. Since the deciding part is a larger sum. Okay. 0 minus 1. देखा यार 477. 1, 0, and 1. That's a lot of time here. That's fine. At least we solved, right? Why runtime error? Oh, wrong answer. Like this. Count connected subgraph with even node sum. Trying to we are currently. Given undirected graph with n nodes, label this node I has a value this. It is either 0 or 1. Age of graph are given by 2DL. It's this. So directed or undirected, between A within this from the non-empty set S graph is going to induce subgraph of S generated which keeps all the node in S. It is only node if ends are both. The induced subgraph S is connected. Sum of node in S is even. In non-empty subarray S nodes in a graph, we consider an induced subgraph of S generated as follows. We keep only the node in S. We keep only the edge nodes 2 and are close in S. Okay. Return an integer representing the number of non-empty subsets as of node in a graph such that this subgraph S is connected to some. Acha, it should be connected and even. Sum is even. It's pretty low here. You can use this mask, right? Yeah. You can use this mask. One, like how we can implement this mask is like this. Let's say we have 1 and 0, right? 1 means we are including that in our subgraph. 0 means we are not including. Yeah, that is what. In answer is equal to 0 for I into I is equal to 0. I is less than equal to less than equal to or 1 let's shift by and. Mm, let's say n is equal to 2. 0, 1, 2 minus 1. Okay, okay, got it. Should not replace. I plus plus. Okay. We we keep only the nodes in S. We keep only the edge whose both have whose both endpoints are in S. Okay. So let's create a set in SP, which are the node we will include here. 0 to n minus 1 we have, right? Yeah. So we'll int j is equal to 0, j is less than n, j plus plus. If I and 1 right shifted by j, so this node will include. So SP dot insert uh, j. Let me first check. N is this size. This is our n. We out I. I is equal to 1. We're not including any. I is equal to 1, we are including 0. Yeah, okay. We're including 1, 0, 1, only 2. Are we okay? We are getting 0. We are getting 1. We are getting 0, 1. We have 2. We are having 0, 2. We are having 1 and 2. We are having 0, 1, 2. Okay, this is what we want. So this we are getting a set, right? So now these are the node we are including our subgraph. From this subgraph, we have to generate a graph. Okay. And then we have to check that graph is connected. Also, we have to check that sum of that graph is even. If this all conditions satisfy, then only we'll consider that this is a valid subgraph. Okay. So let me first create edges, right? We already have edges here. Let me create a vector of vector in adjacency list here of n. Mhm. Yeah, is equal to 0, else there's uh, auto in person u comma v from edges adj of u dot push back v adj v dot push back u. Okay, so we have edge. Now we have to create a new, what we have to create? We have to create a new subgraph using these nodes. For that, we have to create a new adjacency list. New adjacency list of n. Okay. So now we simply iterate with this set. Let's say node. Yeah. So now we have to iterate all the childrens of this node. Yeah. Now, if we have to check if the children is present. Dot find child is present is not equal to s2 dot end. That means we have to add this edge. Node dot push back to children, and similarly for this children we'll push back this node. Okay, so we have created a new graph. Now we have to check this graph is connected or not. If this What's the condition? If graph is connected, then the number of component is 1. If we get number of component greater than 1, that is graph is disconnected. Hmm. The number of connected component is greater than 1, then it is disconnected. Okay. We can do DFS. Yeah, we can run a DFS here. So for that, let me create a vector of int visited. Okay. If this is visited, we can do BFS or DFS, doesn't matter. We just need to visit all the let me I don't want to create a new function. So use q q of int q. Okay. Visited of these are the nodes. What I can do is I will iterate through all the nodes that are present in set, and let me create a new set called visited and q. Okay. Or is there any better way? I just need to find the connected component. DFS is the good way. DFS is the simplest way, but I don't want to create a new function. So we need any traversal. If it is DFS or BFS, doesn't matter, right? You just need to visit in this format. So for this child, so for this node, I need to visit is all children. Yeah, while queue is not empty, while not queue not empty, let me pop the first visit dot push back s dot begin star s dot begin and q dot push star s dot begin. Okay, so the temp is equal to q dot top q dot front, right? Q dot front and q dot pop Wait. Let me do DFS only. For auto expression X over ST, if set of in visited, if visit dot find X is equal to visit dot end, that means we have to run DFS for this node, which this and with this. Okay, and we'll do count plus plus here, and let me write a DFS. Void DFS in node and adjacency list. Then a visited set 10%. Okay. So what we do here for auto ampersand child of this new adjacency list of this node. Okay. So what we'll do is if visit dot find child is equal to visit dot end, then we visit this child and we run DFS from this child adjacency list and visit it. Okay. And let me find the sum for auto ampersand X over ST. Sum plus is equal to 1 say phi of X. If count is equal to 1 and sum mod 2 is equal to 0, then we'll increase our answer. Okay, should be X. Where we are getting error now. Wait, why only 1? Wait, why I'm not getting all the elements this time? Getting right? Let me see out something. See out the count and see out the sum. I is equal to 0. If set is empty, then because size is equal to 0, then zero and continue. Count is equal to 1, sum is equal to 1. Okay. I is equal to 2, this is it. Count is equal to 1, sum is equal to 0. Okay. I is equal to 3, 0 and 1 are included. Count is equal to 2, and sum is equal to 1. So this is not correct, right? So connected components are getting 2. Uh, yeah, X, X, yeah, start searching for this X. 0 and 1. X equal to 0 is X equal to Y. Y started insert child. Wait, 0 is inserted or not? X equal to 0, start is 0. X equal to 0, start is equal to 0. That means we started wait, let me print this again and see. For also in person X over and ADG for also and person Y over X. And yeah, also Y. Yeah, and I is equal to 1. This is how it is, right? DFS. 6, 4, 3. Set is equal to 0 and 1. Oh, it's empty. Yes. We are getting the right answer, right? Let me check. Let's not bring this. Count is equal to 1, sum is equal to 1. I is equal to 4, we are including only 2. Count is equal to 1, sum is equal to 1. Okay. I is equal to 5, we are including 0 and 2. No 0 and 2 are disconnected. So count is equal to 2, and sum is equal to 2. 6 means 1 and 2. Count is equal to 1, but sum is equal to 1. 7, 0, 1, 2. Count is equal to 1, sum. Okay, it's look good to me. Submit. Yes, we are good to go. We solve three problems, and I break my inconsistency of not solving three problems. Can we make a strike? Streak. Sorry, it's not a strike. Can I make a streak to solve three questions tomorrow, right? Yeah, pretty good contest today. I understand the question very carefully, and my thinking process also clear today, right? So that helps a lot. No, don't say 4K rank. Please don't say it's a 4K rank. Why 4K? It should not 4K, right? Direction. Why 4K? Yes, we are not 4K. We are 1K. Around 2K, I mean. Why? This is not updating in real time. I'm satisfied with my. Yes, we are not 4K. Maybe we are not 4K. Can I try this question? Kth small remaining in even integer in a sub-array query. Sub-array. Okay. What's the constraint? See, constraint is pretty big, so we will not think about mass, bit mass here. I think it's today we'll get a 2K rank. K smallest remaining even integer in a sub-array query. You are given an integer array nums, where nums is a strictly increasing. Okay. You're also given a 2D integer array called a query, where query of I is LIRITI. Consider a subarray from L to R from the infinite sequence of all positive integer, even integer. Remove all elements that appear in a subarray. This find the kth smallest integer remaining in a subarray after in a sequence after kth smallest integer remaining in a sequence after removal. Return an integer array answer where array is the answer of I query. Okay, so I got it. So we have an infinite series of even number, right? In each query, we will delete all the positive, remove all the element that appear, remove all the element that is appearing from this, and it continues strictly increasing. Nums will always have an even number, no, right? So 0 to 2. 0 1 to the 1, 4, 7. So remove element 4 from the sequence and we need to print the first smallest even number in the sequence, that is 2. How we can achieve this? Let me first think. I have tools to achieve this question. Like means I know the concept to achieve this question. If yes, then we'll go for the implementation. If no, then we have to learn that concept. That's the only visible, right? We solved three questions today. Yay! Okay. We have infinite series of given number. So anyway, we don't anyway we'll not track that infinite series. Okay. We just need to track using lazy segment tree. 10 to the power 5. Yes, we can use a lazy segment tree here. Yes, we can use a lazy segment tree here. So how we can use lazy segment tree here is say for each query. Okay, for each query. First, for each query L to R from L to R, you need how many even numbers you have in this range. And you also need a particular even number. Like, I don't know like what's the optimal. So if I do brute force also, Okay. Okay. Let's say I get X even number in this range. So now I need to delete all the X from the infinite series. And this give us a TLE, time limit exceeded. What's the better job? So what I'm thinking, let's say we have query from L to R. This query, this range has a X even number, X even number. So now we need to delete this. I'm not able to write. We need to delete this X number from the sequence of infinite even number. Like I don't know like how to handle this effectively. Do we know anything? Uh, and the question mentioned that n is always a increasing fashion. N is always in increasing fashion. That is some hint. That's that's the hint. Oh, okay. That means there's always a unique even number you will get from two different discontinue range. Yeah, that's correct. Yes, that's correct. Possible that I can implement. Can I? See, from each range, and it's even number also. So it's not much difficult. No, no, but still, let's say range R1 and range R2. How can I effectively plug out the even numbers which is present in R1? Does I know some optimal way? Is there any optimal way? If yes, then what is that? What's that optimal way? It's a six pointer, right? Not much harder. This is also six. The same difficulty as previous question. Uh, why I hit this one wrong again? I don't know how to extract the even number effectively from the range. Or is there any need to extract? Or is there any better way to keep track of that even number? Uh, no, right? What we can do here? Seems like we are stuck. better way then. Mm, I think, wow, 1777. If LeetCode genuinely removes the cheaters, then the rank should improve a lot. How is even possible in code entire contest in a 2.5 minutes? And I'm sure this is a way. See, anyway, we are not competing with cheaters. This is not my cup of tea. This question is not my cup of tea. Yeah, we perform pretty good today. That's all for today. And thanks for watching. Bye bye.